Okay, in this lesson we're going to take some notes to introduce polynomials, and then we'll also review adding and subtracting polynomials. So we'll just run through a few things that you should probably know about polynomials. A polynomial is a sum of terms of the form ax to the k power, where k is a non-negative integer. Okay, so that means it could be 0 or 1 or 2 or 3 or so on and so forth. Now when it says sum of terms, that does mean the terms could be positive or negative, so you'll see pluses and minuses both. When someone talks about the degree of a term, all they mean is the exponent of the variable. So the k from up above, that's the degree. The degree of a polynomial is just the largest degree of the polynomial's terms. So you would take each term separately, determine what the degree of each term is, whichever is the largest, that would be considered the degree of the entire polynomial. The leading coefficient. The leading coefficient is the coefficient of the first term, assuming the polynomial is in standard form. Standard form just means that the terms are written where the first term is the term with the largest exponent, and then the second term is the next largest exponent, on down until the last term has either the smallest exponent or there's no variable on the term at all. So standard form, when you put it in standard form, the leading coefficient is the coefficient of that first term. A monomial is just a one-term polynomial. So if you only have one term, you would call it a monomial. If you have two terms, it's considered a binomial. And if you have three terms, you call it a trinomial. Generally, after three terms, you just call it back to a polynomial, although all three of those are, when you say polynomial, they're all polynomials. But again, the number of terms determines whether you call it a monomial, a binomial, or a trinomial. And now we're going to talk about adding and subtracting polynomials. When you add and subtract polynomials, all you really do is add or subtract the like terms. So in this first problem, and we have two trinomials that need to be added, and since I have my parentheses, I can get rid of them. And basically what you do is think of what number's out in front. That would be a 1. Right here would be a 1. Since the plus sign is positive 1. So if you distribute the 1, you have 5x squared minus 3x plus 2 plus 2x squared plus 9x minus 11. And we have our 6 terms there. All you do now is find all the terms that are like. So there's an x squared term here, x squared term there. Notice I included the plus sign. Negative 3x there, positive 9x there. And I have two constants, positive 2 and negative 11. And they just add the ones that are like. 5x squared and 2x squared make 7x squared. Negative 3x and positive 9x make positive 6x. And positive 2 and negative 11 make negative 1. There's the answer. Now that's an example of what's called the horizontal method. And that just means we worked it out horizontally. We did everything horizontally. We took all of our terms, distributed, ended up with 6 terms all on a horizontal line. That requires us to then find the terms that are like and make sure we put those together. We can also do this a different way. It's something called the vertical method. The vertical method can do things vertically. And so I would take 5x squared minus 3x plus 2, and then I'm going to be adding
the second polynomial, which would be 2x squared plus 9x minus 11. And when we add, you kind of want to think of having columns. And you include the sign. And now when you add, positive 2 and negative 11 make negative 9. Negative 3x and positive 9x make positive 6x. And 5x squared and 2x squared make positive 7x squared. And there's the answer, which is the same thing we had on the previous page doing the horizontal method. Some people like doing it vertically, some people like doing it horizontally. When you do add, sometimes if you do it the vertical method, you might have to rearrange your terms. This particular problem, it was the x squared term, the x term, and the constant. And you also sometimes have to leave a blank space because maybe there wasn't a term that was like with it. You're making your columns have all the like terms. Now in a subtraction problem, this time when you get rid of your parentheses and you distribute, that's a positive 1 there, but there that's a negative 1. So if I do the horizontal method, and I get rid of the parentheses, I would have 8x squared minus 11x plus 12, and then we have negative 5x squared plus 7x plus 13. And then we'll do the exact same thing that we did for addition now. Just get our like terms, 8x squared and negative 5x squared, negative 11x and positive 7x, positive 12 and positive 13. And the biggest problem people have here are keeping all their signs the same. 8x squared and negative 5x squared is 3x squared. Negative 11x and positive 7x make negative 4x. And positive 12 and positive 13 make positive 25. So there's your answer. Again, if you do it the horizontal method, you're making one long line of terms, and then you have to go through and pick out the terms that are like. Okay, some terms don't have a like term, and so that term would be a part of your answer. Generally, you're writing your answer in standard form, which is what I did here. The first term has the largest exponent down to the smallest exponent, which is the term that has no variable at all, 25. If we go on and do one using the vertical method, in the vertical method, in this one, first thing you're going to want to do is probably rewrite as an addition problem. Where you would leave the first term obviously the same, 8x, or the first polynomial the same, 8x squared minus 11x plus 12. And then as I make this minus or subtraction into a addition problem, then everything inside becomes the opposite. Negative 5x squared, positive 7x, positive 13. And then now you're ready to write it vertically. Put your second polynomial underneath. Just make sure you line up the ones that are like. Negative 5x squared under 8x squared, positive 7x under negative 11x, and positive 13 under positive 12. Keep your columns, which means you keep the sign in with the term. This is positive 25. This is negative 4x. And this is 3x squared. And that's what you have. Okay, so again, the vertical method with a subtraction problem, you do have to make sure that what comes after the minus sign, that you make everything into its opposite before you put it vertical and add. Now, if I give you another example quick, and let's say we had 5x to the third plus 3x minus 8. And let's say we wanted to add 2x squared plus 15. This is what we're going to do. Okay, notice this first polynomial will have no x squared term. So I have 5x to the third. I should kind of leave a space, okay, where there would be an x squared term. Okay, and then I would put the 3x and then the negative 8. And then when I do the second polynomial, 2x squared, and it doesn't go under 5x to the third, it goes here where the space is, okay, where I would have had an x squared term in the polynomial above. And then 15 doesn't go under the 3x, it goes under the negative 8. And then you're ready to go ahead and get your columns, and you can add it. Positive 15 and negative 8 makes positive 7. There is nothing to add to 3x, so it's just plus 3x. There is nothing to add to 2x squared, so it's plus 2x squared. And there is nothing to add to 5x to the third, so it's just positive 5x to the third. And then this is your answer. And you really only had to add the negative 8 and the positive 15 because nothing else had like terms. And that's doing it vertically. If you had done it horizontally, you would have just had your 5 terms. You would have found all the ones that were like and put all of those together.